So, hello and welcome back to my C++ tutorial playlist. And in this video, I wanted to start our first bigger project. And for that, I thought about what could be something that everyone might find useful and where we could also integrate a lot of things into in the future. So we start simple and then make it more and more complete. And for that, I decided to do a to-do app. And to start with that, we will focus on inheritance on this video and remove all the old code that we have from last video. So we start off nice and simple and we just do our usual includes. And we will also need memory in this case for smart pointers, and I think that's it. And first we start with implementing a base class for our tasks. So basically what defines a task. And we first want to have a constructor. And for that, we will have a description, something like this. And we also want to make it explicit. Then steal the data from there. I think that would be a nice way of doing it. Then, of course, we need to have our description, where we can store this data into. Then we would want to have a virtual destructor, so it gets called correctly even in a derived class. And then also virtual void display, so it could be outputted to the console. And for that we will use print line and do something like task, and then put the description here like this. And I think that should already be a very basic base class that we can use. And to explain a little bit, this is the constructor that we use to create a task. And we basically copy a string, the string that we put from outside into here as a value. And then we steal that and move it into our local member variable. And we have this virtual keyword here. So this class will have vtable, or any object of that class will have a vtable. Basically, this is a table of pointers that point to the implementation that should be used. And this is dispatched dynamically. So if this class gets derived, for example, we will do a simple task now, and the simple task can then override these pointers to point to a different implementation. And yeah, so we can do a simple task now, and that inherits from our task base class. And that basically means that it inherits all the behavior and data members from the base class. And we can now override the things that get marked with virtual. And we also need to define, of course, a constructor. And the only thing that we want to do in our constructor is to call our task, our base class, with the argument that gets passed in here. Like so. And then we can choose to override the destructor or the display if we want to, or add any new functionality. But of course, we also only want to override the display. And for that, we need to have the same signature as we have here. It also needs to be const. Const here in this context just means that we won't change this object by calling this function. And of course, we also want to annotate that we have overwritten the base class function. So we add the override keyword here, and maybe override in virtual is a little bit overkill. This would be the full signature, but if we see that we have overwritten something, then it has to be virtual, so we can infer that and don't need to specify it here. So that might look a little bit cleaner then. And then we can replace the base implementation with, for example, something like this. And as we can see, we still have access to our base class member variables. And to have a little bit more variety, we can also copy this and have an important task, and change this into important. And here we could maybe add another function, important, for example. But in this context, this doesn't make sense because we want to have the task basically as an interface. And yeah, So this is basically our API that we want to use. So it doesn't make sense to have additional functionality here because we will only have a container of tasks and won't have any single important tasks. And we can also inherit from STL containers. So let's show you how to do that. For that, we will create a task list and inherit from task like this. And here we can maybe create a new method like display tasks. And we will also make this const. And here we will just use a for loop for const auto reference task and this. Then we will just call task.display, and here we will then always use the display function here, because we know a task must have a display function. It might be overwritten by a simple task to display simple task, or by important task to display important task. But we know by using the task as our basically interface description or our base contract on what a task should have at a minimum, we know that it always has a display function or a display method. So we can always call that, and through the vtable of the virtual functions, it gets resolved dynamically into either this implementation, or this implementation, depending on if the object stored here is a simple task, important task, or a task. And maybe let's also implement an add task and have const task reference task. And this is not const because we will modify this. And here we will push back the task like so. And I think that's already it. That's already everything that we need to implement to have a simple to-do list. So let's write a simple to-do list. To-do list. Add task, and then we can push back a simple task and have a description in here to homework. And let's see, of course, this all needs to be public, and same applies here. And of course, this is our to-do list. And with that, we would have added a simple task. Then maybe let's add a regular task like this, and I don't know, go for run. And then an important task might be, I don't know, finish assignment. And with that, we could then already display our tasks and have a simple task list. And as we can see, we have our tasks here, but for some reason it didn't call the right implementations. So that might be the case if we cast it into a task here and also have a list of tasks. But I think we need to have unique pointer task like this, and then we would need to do it like this. And of course, a unique pointer can't be copied, so it needs to be moved. We have this right here. And of course, it also needs to be std unique pointer task like this. And here we need to wrap it inside of std make unique like this. And same applies here, of course. It needs to be a task. Like so. And now that they are pointers, it should work correctly. Let's see if it does work correctly. So let's see. It is not too happy with that. And I think the easiest way we can change that is to move it in here. Otherwise we would need to move it here to make it a R value reference. But I think it would be easiest to do it like this. Let's see if that worked. And as you can see now, it works, everything gets dispatched correctly. We have a simple task now, do homework, a task, go for a run, and an important task, finish the assignment. And we can, of course, play around further with this. We would, for example, like to remove something, offer something like this, and do it like this for simplicity. And if we compile it now and run it again, then we can see that we have removed the first task and have now 2 other tasks, like so. And I think this should already be the basis of our project, and we will continue with that in the next video. And I hope you have seen how to make a base class and also derive from that. You should also have seen how to derive from standard containers, so you can expand them to add your own functionality. And yeah, this was the whole point of this video. And with that, see you in the next one.